Section 9.2, Quadratic Functions. The objective of this section, to graph quadratic functions of the form y equals ax squared plus bx plus c. An essential understanding, in the quadratic function y equals ax squared plus bx plus c, the value of b affects the position of the axis of symmetry. Consider this situation. You throw a ball straight up into the air and catch it at the same height you released it. The parabola shows the height h of the ball in feet after t seconds. What is the total distance the ball travels? For how long does the ball travel up? Explain your reasoning. I'd say one of the first things we need to accomplish right now is to make sure that when you see this parabola, you don't see this as being like an Angry Birds style parabolic flight of an object. Recall, our ball is flying straight up and straight down. The y-axis of this graph represents the ball's height in feet. The x-axis doesn't represent its horizontal distance from us, like the Angry Bird example. It just represents the time. So we might think of a ball at time 0 when we initially throw the ball. It's at whatever height we begin the throw. Looks like about 4 feet. Yeah, 4 feet. And then the ball travels straight up and then straight back down. But our parabola is relating to us the height of the ball after a certain time in seconds. So to answer these questions, what is the total distance the ball travels? Again, remembering that the ball is traveling straight up. So I decided we needed a ball for this example. So here is a ball, and notice the path of the ball, it's going to go straight up and straight back down. The question is, what is the total distance the ball travels? Well, considering the graph, the ball begins at 4 feet, and it travels, as we know, straight up until it looks as though, reading the graph, it ends at a height of 8, 16. Every increment must be 4 feet, so 20 feet. And it began at a height, don't get ahead of yourself and think that it must have reached or traveled 20 feet to reach its maximum height. It's actually traveling from a starting point of 4 feet above ground, and so therefore the distance traveled 16 feet, so 16 feet up. And then, of course, reaching its peak, and gravity continuing to take effect, returns it down to its starting position, another 16 feet. So the total distance the ball has traveled is 16 times 2, which of course is 32 feet. For how long does the ball travel up? Well, considering our parabolic graph here, the ball is traveling up for exactly 1 second. And then symmetrically travels down for exactly 1 second before returning to its original height. So for how long does the ball travel up? 1 second. And then to wrap up our solution, well, it says explain your reasoning. So we'd say something like the ball traveled a total distance of 32 feet. That was 16 feet up and 16 feet down. For how long does the ball travel up? We'd continue in our explanation. The ball traveled upward for exactly 1 second. This parabolic graph shows us that. The parabola in the solve it problem we just completed has the equation h, we can assume that represents height, equals negative 16t squared plus 32t plus 4. Unlike the quadratic functions you saw in previous lessons, this function has a linear term, 32t. A quick reminder for you, we call the first term, or in this case the negative 16t squared term, the quadratic term in a quadratic function. We call the 32t term, note how t is raised to the first power, we call that the linear term. And then 4, in this case, we call the constant. Note if we had to write a variable in there, a t, it would be t to the 0 power. And we know 4 is just a constant. It's a number that just remains a number. In the quadratic function y equals ax squared plus bx plus c, the value of b affects the position of the axis of symmetry. So in this section, we're kind of leveling up. We're learning a newer, more complicated style of these functions where the axis of symmetry may or may not be the y-axis. To see some examples, check out the functions below. You may also want to graph some functions on your own using a graphing utility like Desmos in order to experiment with different values for our linear term and possibly our other terms as well, but coefficients of t or x or whatever our input variable is, to see just how those affect the graph. So here's our first, the top left. The equation is y equals 2x squared. So note, our linear term, if we were to write that in there, is going to be plus 0x. And so therefore, because of the 0b term, we will have a parabola that's symmetric about the y-axis, meaning it has an axis of symmetry of the y-axis. The equation for that we can see below. The axis of symmetry is x equals 0, but we more often just call that the y-axis. Moving to the right, consider the equation y equals 2x squared plus 2x. Well, note now, if we take b over a, interesting, so our linear terms coefficient divided by our quadratic terms coefficient, we get 1. Our axis of symmetry is that x equals negative 1/2. So you may be struggling at this point to see a connection between 1 and negative 1/2. Try to keep that in mind. Well, and maybe even consider back to our first example. 0 and 0. Well, that connection seems easy to make. 1 and negative 1/2. Keep that in mind as we move ahead. Here to the bottom left, our equation, y equals 2x squared plus 4x. Note b over a is 4 over 2, and that's just 2. And notice our axis of symmetry, negative 1, which the book is kind enough to point out to us, can also be written as negative 2 over 2. We should be beginning to see a pattern here. But let's make that a little more concrete with a fourth example. The equation y equals 2x squared plus 6x. b over a is 6 over 2. We know that reduces to 3. And hopefully without looking at the bottom, I haven't yet, you can recognize how to find the axis of symmetry's equation using 3. Well, the common pattern here is to insert a negative, right? Like negative whatever b over a equals, we multiply that by a negative 1/2. Notice that works in each of these cases. 1 times negative 1/2 is negative 1/2. 2 times negative 1/2 is negative 1. 3 times negative 1/2, negative 3/2. And here's that rule stated explicitly for us. The equation of the axis of symmetry is x equals negative 1/2 times b over a, which can be written another way as x equals negative b over 2a. Should sound familiar at this point. A key concept, good thing to take note of or add to your notes. Graph of a quadratic function. The graph of y equals ax squared plus bx plus c. Note a cannot equal 0. Take a moment to think about it. You'll probably understand why. Has the line x equals negative b over 2a as its axis of symmetry. The x-coordinate of the vertex is negative b over 2a. If you're struggling to understand that, don't worry, it should become more clear as we do some concrete examples, and I will try to do a good job of pointing out for you the connection between the x value of the vertex and the equation of the axis of symmetry.